Here we are, getting ready to go out to the pad in our launch escape suits, which are relatively comfortable at this point because they've been cooled down pretty well. Nice day. It was wonderful to see so many folks there to see us off, and we had a very pleasant trip out to the pad.
Here we're picking up with the launch sequence. As a result of our first scrub, the attitude in the cockpit was actually relatively relaxed. Of course, there's a limit to how relaxed you can be when someone lights off that big torch beneath you. Here's the orbiter going by the launch tower, clearing the tower. See the orbiter or the vehicle roll to place us in a heads-down attitude and to align the vehicle in the proper azimuth for its ascent phase. Here's a sequence taken out the overhead window using the handheld camcorder. We'll show you a little more of that later on. Continuing on up in first stage. As Dave mentioned, we were wearing the launch escape suits this time around. They provided a little more acoustic insulation, and it seemed a little quieter to me than my first flight. I think that was shared by the other crew members that had compared it to previous launches. The next sequence will be the IUS deploy.
Once you get on orbit, we got the payload bay doors open, and we took a good look at Magellan. It was good to see that it was in the same pristine condition as when we took off. We started the elevation procedures for the deploy. And inside, once we got on orbit, we had to reconfigure a number of systems for on-orbit operations. Dave reaching back to one of the overhead panels and Norm helping him out. And shortly after that, we started into the procedures that we use to deploy the IUS. Principally, it's the panel in back of me and over to the right of Norm. Once we elevated up to 29 degrees and then on up to 52 degrees for the deploy, we went ahead and threw the switch and sent Magellan on its way. It comes out of the payload bay at about half a foot per second, and during the first minute we just sit there and watch it leave the orbiter bay. We're in free drift as far as the shuttle is concerned, and the way it is deployed, as you know, is a super zip. It's a mechanical or a metal band around the IUS that is separated, and several springs send it from the payload bay. IUS here, it's flown. It's a very, very reliable upper stage. We used it several times, and it put Magellan on its trajectory. The attitude was good, and it was within 3 meters per second of where they said it was going to be, which is pretty remarkable performance. So it's been a real workhorse of the space program, especially return to flight after Challenger. And right about this time, you'll see the rate pickup of the payload. It's when we put a -X burn in to the orbiter. It separates us from the payload, and that's the last maneuver that we do until 15 minutes after deploy, when we go ahead and do our separation from the IUS. This is a shot taken out the overhead window, close-up view of IUS. It's about 400 to 500 feet away. When we finally do our burn, it's about 1,000 to 1,500 feet away, and this is the business end of the IUS we're looking at right here. Inside the gold insulation is the IUS solid rocket motor. And this is when the solar arrays deployed. They deployed 10 minutes after the IUS was deployed in connection with the RCS system on IUS being activated. And this is a nice shot we got. We initially thought that Venus was going to be too close to the sun for us to even see, but we didn't realize till we got up there and followed it several times after sunset. We could see Venus trailing the sun at the terminator. So we got a picture of Venus sunset, and down in the lower portion you see some of the clouds, that thunderheads that had built up.
We had a mid-deck experiment called a fluid experiment apparatus, which you can see here. My hands are inside of this. It's a little furnace. We were growing indium crystals. It was really an excellent mid-deck for us to work on. We changed out samples and actually interacted with the science. Here's an example of the crystal. The rougher section to the right was done at a lower temperature than this striated section, which was melted at a higher temperature. So by adjusting the wattage, we could adjust the temperature which this indium was being melted. If you get it too high, it'll break. If you get it too low, it doesn't melt through. So it's sort of touchy. And actually, the wattage was different on orbit than it was on the ground by about 10 watts. We controlled it with our little experiment computer, which worked great, different floppy disks for each experimental run.
We perform a number of medical experiments each flight. This shows Mark getting censored up for one such experiment, which looked at some physiologic parameters, I believe, like heart rate and that sort of thing. And in this scene, you see Mark and I getting ready for a pre-breathe. When we do spacewalks, to avoid bends, we have to breathe pure oxygen for a while. Mark and I were the spacewalk crew members if we had to do something like that. And for operational reasons, to shorten up that pre-breathe, we like to lower the cabin pressure to 10.2 psi, and we plan to do that on future flights. So to test all of that out and see how the cabin behaved, we donned the helmets in the cabin, and we actually did the 1 hour pre-breathe as the cabin pressure was being lowered from the normal 14.7 down to 10.2 psi. And I'm over there checking out and making sure that our oxygen is actually on. We also have laptop computers. You can see one of the ones we carry here, the PGSC, and you can see what that screen looks like. They're very useful for experiments and for keeping track of where we are around the world for Earth observation purposes.
This sequence picks up with some of the typical on-orbit operations. This is me in the pilot's seat checking out some systems. This is in conjunction with the depressurization to 10.2 psi cabin pressure that Norm talked about. Here's Mary at the overhead windows. This is our primary vantage point for Earth observation photography. Here's some pictures of some thunderstorms approaching sunset. One of the experiments we had on board dealt with the photography of lightning, and here we are getting ready to set ourselves up for that. Here are some lightning flashes as seen by some of the cameras in the payload bay. There's a nice one coming up here shortly. There it is. There's a rather large lightning discharge. Back to flight deck operations. This time we're entering a maneuver to put the shuttle in a new viewing attitude. Here's Norm in back of me entering some data into the onboard computer, the portable computer, that is. Mary again at the aft station with one of our 70mm cameras. Here's a little example of some of the Earth obs. These are irrigation fields, circular irrigation fields in Saudi Arabia. There are hundreds of these, and some of these are very, very large, the diameter getting up to 2 to 3 kilometers across. They're very prominent when viewed from low Earth orbit. We are coming across Baja, California. Sunglint in the Sea of Cortez. And panning down to the southern tip.
We all got a chance to take a lot of photography on this mission, and that's a lot of fun to do. And in addition, it's useful to a lot of folks, geologists, people who do cartography, and oceanographers. For the 2 Floridians on board, Dave and myself, we love this shot. You can see Alligator Point in Tallahassee there for a while, some of my old stomping grounds, and panning down the peninsula. Things are just very prominent. Lake Okeechobee is very prominent there. You can see all of the Miami area, and that's a huge area these days with nearly 12 million people that the state has. In addition to the motion pictures, obviously we took a lot of still photos, and while this is a camera view, the fact is that with the naked eye you can see almost everything that you can see in this view. This is a picture of the Cape, and you can see the shuttle landing facility, the 2 launch pads, including the one from which we had launched just a few days before. The Florida Keys, just a beautiful view. And you can certainly see the Metroplex area there, the metropolitan area of Miami, and of course Lake Okeechobee coming into view. I really, as a Floridian, love these kind of pictures. And we had, it seemed like all the passes we had over Florida during the mission were like this. Very few clouds, and it's almost like looking at a map, except you don't see any of the boundary lines. As we go to the east, of course, we come to the Bahamas. A nice place for a post-flight trip.
We sort of shared doing the food cooking duties. Whoever got hungry first seemed to be the person that would end up cooking. With the galley on board, I didn't have one on the last one. The galley on board, it made it an awful lot easier and faster to get meals prepared. But it's actually a lot easier in 0G. Going up the stairs in 1G, you have to be careful and take the trays one at a time. You can just grab them and float up in 0G. And we usually ate our meals up on the flight deck. Here's Mark with his VHS or Viroqua High School t-shirt on, or sports shirt, with a piece of beef jerky, just enjoying 0G. Mark it was Mark's first flight. He's a rookie, and he really had a good time. You could tell that he was really enjoying being weightless. He kept playing with his food. I'm sure his mother would want him to do that, but he kept playing with his food. And you can see here all the bags. That's re-entry morning. That's all of our suits, re-entry escape gear that was packaged up in these bags before we unpacked them. You can see it took up a lot of space down here. A lot of times at work I feel like I'm running around in circles, and so I tried actually running around in circles, and it worked up there, and it was a lot of fun.
There's something about zero-G that makes even adults regress. We were always told not to play with our food, but the fact is you can get such interesting effects. Now, the fish crackers that we have there in the plastic bag are primarily for eating. But interestingly, in that plastic bag, they really almost did look like a pack of live or a school of live fish. Ultimately, however, you have to remember that they're there primarily to eat, and there go a school of them. And just like predator fish, you can't resist. And then you've got the problem, of course, of getting those things out of the air before they drift off. And we'll introduce the crew, Ron Grabe, and then having some difficulty getting through there as he's tangled up in all the wires and cords that inevitably seem to be in the way, Mark Lee. And I think I'm next here, and I get a little tangled up in the cords as well. But there's always someone there to grab you if you do get lost in space. And in our persona as Sven and Ole, we try to outdo Hans and Franz with their little girly legs and do our pump you up act. And now, Mary Cleave. Nice aerobatics.
Thanks.
And Dave.
Okay, we thought our last day on orbit would be a pretty easy day. We're going to do some more crew movie and Earth Obs type of video work, but we ended up changing out the computer, and this is a real good shot in the avionics bay where we had to work. It was pretty tight, but being in zero-G, there were no real pressure points, so it was pretty easy to stay in there for a couple hours and do the work. One of the biggest problems is housekeeping. As we brought out each one of the wire bundles, we made sure that it was marked correctly. Mary and I both checked them to make sure that when we put it back together, we put it back right. It would have been pretty embarrassing if we wouldn't have got the right cables hooked up. And so we marked everything, we put it in bags, all the screws and bolts float around, so we had to make sure that we kept track of all of those. And once we got it back in, Mary's showing here torquing down the bolts. Each one of the bolts has specifications. This was 100 inch-pounds that we had to do these two, and there were a couple other eye bolts that we had to go to 30 inch-pounds. Once they were in place, then we hooked up all the electrical connectors, we powered it up, and the computer worked great.
After getting the computer replaced, we got a good night's sleep, got up the next day, suited up to come home. This is just a little demo of how that can be done. It's fairly easy to get in and out of the suit in zero gravity, although it isn't all that comfortable to wear. And then we started downhill on schedule. This is a picture of plasma interaction around the orbiter, which Mark was able to get with the camcorder. There's some spectacular photography there of the plasma sheath discharging. This is pretty rare photos. Then you can see out the window, again with the same camcorder, the Earth horizon as we do the roll maneuvers that allow us to guide ourselves down the reentry track. All of this went very smoothly. There's a little bit of high Mach buffet, and you can see that reflected in the slight shaking of the camera. I said Mark. Actually, I think Mary was taking all of these. And Mark took the photos uphill. And then finally back at Edwards, Ron flew a little bit after we went subsonic, and then I took it for the landing. It was very smooth all the way down till we got close, relatively close, the last few thousand feet, when the turbulence and the crosswinds, which we had expected, since we were trying to get a crosswind developmental test objective done, became obvious. So the orbiter flies very well through that sort of conditions. Here's another picture out the side window as we come down. We had no difficulty approaching the runway. Some mild compensation for the crosswind. And then, as you'll see, it lands pretty smoothly. Ron is going to do the most important job that he has to do in the flight here in just a second, which is to lower the landing gear, which we're very appreciative. Because we switched runways late in the game, we don't have as good a photographic coverage of the landing as we usually do, but it's still adequate to see that the orbiter is flying well. On touchdown, the crosswind becomes more evident and requires more compensation, but still it's quite safely flyable. We had a smooth, soft touchdown, a little bit of drift left, and then back to the center line. Rolled out about 10,000 feet and stopped without difficulty. And after having gotten out of our launch escape suits and cleaned up a little bit, we were ready to come back to Earth, where Dale Myers and Dick Truly were waiting to greet us, and where we could take a look at the orbiter and make sure that it was indeed in as good a shape as we had hoped. It looked fine, and we were happy to be back after what was very exciting, although to our mind too short a flight. We would have been happy to stay longer. And we'll be happy to go back when the next opportunity presents itself.
This time around, they provided a little more acoustic insulation, and it seemed a little quieter to me than my first flight. I think that was shared by the other crew members that had compared it to previous launches. The next sequence will be the IUS deploy.
Once you get on orbit, we got the payload bay doors open, and we took a good look at Magellan. It was good to see that it was in the same pristine condition as when we took off. We started the elevation procedures for the deploy. And inside, once we got on orbit, we had to reconfigure a number of systems for leave the orbiter bay. We're in free drift as far as the shuttle is concerned. And the way it is deployed, as you know, is a super zip. It's a mechanical or a metal band around the IUS that is separated, and several springs send it from the payload bay. IUS here, it's flowing, it's a very, very reliable upper stage. We used it several times, and it put Magellan on its trajectory. The attitude was good, and it was within 3 meters per second of where they said it was going to be, which is pretty.
Here we are, getting ready to go out to the pad in our launch escape suits, which are relatively comfortable at this point because they've been cooled down pretty well. Nice day. It was wonderful to see so many folks there to see us off, and we had a very pleasant trip out to the pad.
Here we're picking up with the launch sequence. As a result of our first scrub, the attitude in the cockpit was actually relatively relaxed. Of course, there's a limit to how relaxed you can be when someone lights off that big torch beneath you.
On-orbit operations. Dave reaching back to one of the overhead panels, and Norm helping him out. And shortly after that, we started into the procedures that we use to deploy the IUS. Principally, it's the panel in back of me and over to the right of Norm. Once we elevated up to 29 degrees and then on up to 52 degrees for the deploy, we went ahead and threw the switch and sent Magellan on its way. It comes out of the payload bay at about half a foot per second, and during the first minute we just sit there and watch it.
Here's the orbiter going by the launch tower, clearing the tower. See the orbiter or the vehicle roll to place us in a heads-down attitude and to align the vehicle in the proper azimuth for its ascent phase. Here's a sequence taken out the overhead window using the handheld camcorder. We'll show you a little more of that later on. Continuing on up in first stage. As Dave mentioned, we were wearing the launch escape suit.